So yeah, my name is Louis, and I'm also from the Department of Microbiology. And today I will be presenting my honors project, which is titled Investigating the Effects of COVID-19 on the gut bacterium and viral in long COVID patients. So as we all know, I assume that the coronavirus disease 19, or more commonly known as COVID-19, is caused by the severe acute respiratory syndrome coronavirus 2. And SARS-CoV-2 mainly infects cells in the respiratory tract via the ACE2 receptor, which is present on the cells or respiratory cells. And after infection, it can lead to mostly flu-like symptoms, and in severe cases, it can lead to pneumonia. And although COVID-19 has had an impact on most individuals globally, some individuals have been shown to have a higher risk factor for severe COVID-19 outcome. And age have been shown to be the highest risk factor, with increasing age resulting in an increasing risk for severe COVID-19 outcome. And other comorbidities which were linked to severe outcome included hypertension, diabetes, and obesity. And although SARS-CoV-2 mainly infects cells in the respiratory tract, it has been shown that it can actually translocate from the lungs to the gut via the gut-lung axis. And after SARS-CoV-2 manifests in the gastrointestinal tract, it also infects cells via the ACE2 receptor, and then it can damage the gut epithelial cells, and it can often then lead to a gut microbial dysbiosis. And individuals then often can experience digestive symptoms such as diarrhea and vomiting. And although COVID-19 infections usually last between 1 to 4 weeks, some individuals have been shown to develop persistent symptoms, and scientists have termed this condition long COVID. Now, long COVID includes a wide variety of symptoms, such as loss of taste and smell, brain fog, various respiratory syndromes, and diarrhea, just to name a few. And recently, during the pandemic, it has been shown that it can affect the GIT, and this is one of the mostly affected organs or organ systems. And because of this emerging problem, many studies have been focused on, or has been conducted on long COVID and its effect on the gut microbiome. However, there has been a lack of studies being conducted on the effect long COVID has on African gut microbiomes. And therefore, this study aimed to bridge that knowledge gap and to determine the effects COVID-19 infections have on the gut bacterium and viral in patients with long COVID. So to achieve this aim, I had three main objectives. The first two being investigating the bacterial and viral composition in the stool samples obtained from the long COVID patients. And the third objective was to determine the diversity of observable metabolic genes in these viral communities. However, for the purpose of this presentation, I'll only focus on objective 1. And furthermore, we hypothesized that the prolonged exposure of SARS-CoV-2 will significantly impact the composition of the gut microbiome in these South African long COVID patients. And then for the study, 6 long COVID patients were recruited, and ethical clearance were received or obtained by the University of Pretoria, and stool samples were also collected and supplied by the University of Pretoria for this study. And then from these 6 patients, 5 were female, and all tested negative for HIV. And it was also important to note that 4 of these patients were self-diagnosed as overweight, which can have an impact on the gut microbiome, as it can, or they were self-diagnosed, so they might have had obesity, which is a metabolic disorder which can significantly impact or play a role in shaping the gut microbiome. And then for my controls, I obtained raw sequence data from the NCBI, and I selected the study from Tamburini, which was also conducted on African gut microbiomes, assessing the gut composition of rural and urban, or individuals living in rural and urban areas respectively. And all the participants in this study were female, and all also tested negative for HIV. And then from the stool samples obtained, we performed DNA extraction, and then high quality DNA was sent for shotgun metagenomic sequencing. And after we obtained the raw reads, we subjected to quality control using FastQC. And after assessing the quality of the raw reads, we trimmed the low quality reads and only used the high quality reads for further processing. And then the high quality reads were assembled into contigs, and the contigs were built into metagenomic assembled genomes. In this case, I call it bin 1 and bin 2. And then after we did taxonomy classification using 3 different bioinformatical tools, namely Kaiju, GTBTK, and ReRAP. So Kaiju we used to assign taxonomy to the high quality reads, and then GTBTK were used to assign taxonomy to the metagenomic assembled genomes, or MAGs. And then ReRAP were firstly used to assign or create viral MAGs from the contigs, and then assign taxonomy to these viral MAGs. And then for my first objective, we assess the bacterial composition in the 2 groups, the long COVID and the healthy controls. We first visualize it by various alpha diversity indices, and this accounts for the diversity within the 2 groups and assessing the difference between the microbial diversity of the 2 groups. So firstly, the Shannon and Simpson diversity indices show no significant difference between the 2 groups. And then the species richness, although the healthy controls had a higher species richness, there were no significant difference between the 2 groups. However, we did see a significant difference in the CHA1 index, which estimates for the true species richness and account for rare taxa more. So this implies that there were a more abundant rare taxa in the long COVID individuals compared to the healthy controls. And then for the beta diversity, which assesses the difference in microbial composition, we also observed no significant difference between the 2 groups of their microbial composition. And then we visualized it, we visualized the relative abundance of firstly bacterial phyla. And in figure 6a, we created a stacked bar plot. And it's notable that the Bacterodota and Bacillota phyla were the most abundant. And then we further performed a Wilcoxon rank sum test to test for significance. And we saw that the Bacillota phyla were significantly enriched in the long COVID individuals. And the Bacillota phyla, which is previously known as the Firmicutes, has been shown to contain opportunistic pathogenic bacteria in this phyla, which can indicate a sign of dysbiosis in the long COVID individuals. And then on the general level, we firstly saw that in figure 7a, we saw that Prevotella were notably higher in the healthy individuals compared with the long COVID patients, and Prevotella is also known to be a beneficial bacterial genera. So this can, the decrease of this genera in the long COVID individuals can also indicate a sign of dysbiosis. And then we again performed the Wilcoxon rank sum test to test for significance in these bacterial genera. And in figure 7b, I summarized the 4 bacterial genera which were significantly enriched in the long COVID individuals, and these included Glaucia, Coccococcus, Dorea, Mediterranean, all 4 of which belongs to the Bacillota phyla, which further supports the evidence that the Bacillota phyla was significantly enriched firstly, and that it can indicate a sign of dysbiosis. And then lastly, we created a phylogenetic tree with the MAGs, and it's again notable that the Bacillota and Bacterodota phyla were the most abundant phyla in both of these groups, both the long COVID and healthy controls. And it was further interesting that the Bacillota to Bacterodota ratio, which is often used as a biomarker for gut dysbiosis, were notably higher in the long COVID individuals than the healthy controls. So just some key observations specifically on the bacterial communities. Like I mentioned, the high Bacillota to Bacterodota ratio in long COVID patients compared to healthy individuals were notably higher, not significantly higher, but notably higher. And it has been used as a biomarker for gut dysbiosis. However, most of these studies were done on obesity or other metabolic disorders and not necessarily long COVID-19. And this translated to the general level as well, where the 4 bacterial genera which I mentioned were significantly enriched in the long-COVID individuals have been shown to, or have been associated with gut inflammation. However, again, this finding contradicts most COVID-19 studies where they actually observe a significant decrease in these bacterial genera. And then, although we didn't came to definite conclusions yet, this is one of the first studies to characterize, or aim to characterize, the gut microbiome of African long COVID patients. And we did observe signs of gut dysbiosis, according to previously described biomarkers, which mostly links to obesity and not necessarily long COVID. And yeah, although we described who is present in the gut microbiome as a whole, they still need to determine why these microorganisms are there, to determine their function, and this can be done through functional analysis. And then I just would like to thank various people and institutions for their help and support with this study. Yes, thank you.
Thank you so much. Any questions from the audience?
Thank you. So, with honest studies, we all know that you have limited time and limited scope. So, if you could continue this study as a master study, what weaknesses in your current study would you like to address? So, how would your study design differ from what you had for your honors?
Yes, so of course, I think not necessarily the biggest limitation, but the limitation of this study was the cohort size. So it's always difficult to get participants, so I think that is, if that could be improved, I would like to improve that to get a bigger cohort size. And although the time was limited for this study, I would also, and I will continue with the study and do, like I mentioned at the last point, the functional analysis to determine, for example, the certain metabolism these microorganisms are taking, to distinguish or to determine their specific function or their role they play in the microbial community. As many of these microorganisms, those 4 genera I mentioned, which were significantly enriched, but they actually are also healthy bacteria, but in some cases they can kind of switch on to be bad. So I think to determine why that is the case, yeah, I think that to continue along that road.
Thank you. One more question.
What I want is kind of similar, but I wanted to ask, how can you be sure that, like you mentioned about the amount of people that you had actually participate in the study, and I noticed that your control group was much larger than your actual, the people who were affected by long COVID. Plus, the obesity definitely skewed the results. But I wanted to ask, when you're actually collecting the gut information, are you sure that people aren't taking probiotics? How could you be sure that they're not taking probiotics, how they're sticking to specific diets? Wouldn't those things sort of affect the results?
Yes, of course. So regarding the probiotics, obviously that will have an impact on the gut microbial composition. I'm not sure if they were on probiotics, but regarding the diet, this is kind of one of the main reasons we do these studies on African individuals as well, because there is a lack in that, and there's a huge difference in microbial composition in people that have different diets. So yeah, the diets play a very important role, and that's kind of the main, not the main reason for this study, but the reason you have to study different groups of people as their diets differ, and of course the genetics as well, which also play an impact in shaping the gut microbiome.
Thank you so much.